Hello guys, welcome to my channel again, and today my topic is how to create a deep learning tensor REST API from the scratch. So I have already created this source code. You can use already pre-trained application. I guess I believe that you guys already have knowledge of some basic keras and TensorFlow. So in TensorFlow, uh, in Keras applications already pre-trained weights are available, so you can call any type of pre-trained weights, and whatever the type of classification system you would like to create, you require a data set for that type of classification. I'm going to use a specific type of data set for now, like just a second, let me create a data set for you. I actually have couple of data set here, so I'm going to create a data set which can be used for specifically in this tutorial. So I'm name it main data. Okay guys, and I'm putting those folder here. I'm going to use only 3 folders, consist 325 of images, and the labels are available here. Okay, so let me call these folders. So okay guys, globe is a built-in library available in Python, a library available in Python. When I put this when I call this library, it give me the information, the available folder inside the main data. Okay, from those folder I can get the images available inside it. I create a list and append those image path in a list, and their labels mean their name. Okay, their labels like concerning, cancer, granular, annular. Okay, labels will be appended here. Moving forward, okay, I read those images as those images are collected from internet. So some of those images are not RGB, some of those images are in RGB bands, so more than 3 bands images. So every image, whatever I read, I will convert those images in RGB format first, and thereafter after converting RGB format, I reshape them so that I can put it into the pre-trained model. Here I'm using the pre-trained weights efficient B1. You can use any type of pre-trained weights, but efficient B1, B0 to B5 are the latest available weights here. So I'm going to use efficient net. So you can actually you can call those weights like from TensorFlow. It's really easy to use those pre-trained weights, and always use headless if you are going to train it for the custom data set. Headless means that already these weights are being trained for 1000 classes. I'm going to use efficient B0 again in this video for you guys. Previously I have trained it with B1. So when I run this example, it basically load efficient B0 weight, and if the weights is not available in your computer, it directly downloaded from internet and saved into the main library site directory, where it can if it required further, it can reload without even downloading. Okay, ImageNet weights is ImageNet means I'm using pre-trained weights. Include top false means I'm not using the last layer, which is for trained for 1000 classes. Once I call this method, okay, I need to add my number of classes. Here I'm using 3 folders, so I need to put here 3. Okay, and the output of this will be fed to my my local global. We need to flatten those layer. Okay, so after for flattening, I'm using here global average pool 2D, but you guys can use anything, like you can use dense layer, even the flatten layer here. Like flatten also do the same. So for calling that flatten layer, all you need to do, just x is equal to flatten, and it will flatten the layer automatically like this. So I'm not using flatten here. I'm actually global average pooling 2D. Basically it has a few advantage over the flattened layer. So I will be getting more tuned features here. Finally, last 3 layers, one additional layer for one additional dense layer for further fine tune of the model. Okay, my model input is base model input. By default, this model input is 224 image size, and for RGB band, and output is prediction, like for dense prediction. Okay, this model, the summary is being printed when I call this model. Okay, optimizer, I'm going to use Adam. Loss is categorical cross entropy, matrix accuracy. Okay, this is for variable learning rate, so that I can get best trained model. Okay, early stopping if model won't be training. Okay, and finally the test accuracy will print, and my frozen graph, that means pre-trained weights, will store in the temp directory by the name of the folder 444, which further being used for the production purpose. Okay, if you guys want to integrate that model directly on the mobile application, Android and iOS side, or on React Native, okay, this is you can export that model into lightweight format, and the extension is TF Lite. So I'm running this. Let me run it for 10 epochs only, so that will take less time. Okay, and I have run this model. So these are the 3 classes. My model training images shape. 33 images is used for the testing purpose, and 292 images for the training purpose. This is for the current, like as I already told you, if weights is not saved in my directory, this will be downloaded from the source. Okay, and no top means that I am not using the top layer, which is being trained for the 1000 classes, and as such I am having 3 classes only. This is a very huge heavy weighted model, having trainable parameter 5 million, more than 5 million, and non-trainable parameter 42,000. Okay, the difference the meaning of trainable and non-trainable parameter is simple. Trainable parameter are those parameter which keeps on changing during the time of training, and non-trainable parameter like batch normalization one, which remains same since the beginning till the end of the training. Okay, as I have less number of images, my model is being trained. My training accuracy is 99%, and testing accuracy will around 60%. Okay, and once the training is done, these warnings showing nothing. My model is saved. Let me reach out to that model. Okay, it's in temp directory, so let me move to the temp directory first. So recent model is 444. This is the weight. This save model.pb consists the model parameter and these variable. This variable hyphen dot data hyphen penta not hyphen off hyphen octa not 1 me store the entire numerical matrix which used for the classification. So I'm going to so let me copy this one somewhere. Okay, I have pasted here. Okay, now let me open the main thing. I'm the tensor rest serve thing. As basically why we require tensor rest serving is tensor rest. Why we require tensor rest serving is because as such when we deploy these weights directly or creating a Flask API and call this method as use for prediction, this has no use because TensorFlow is, as such is not that much threat proof. So when more than one request comes at a time, this will break the model. Okay, so you guys can learn about the TensorFlow REST serving API from this link. I will put this link in the discussion section of the video. So so whenever there are few libraries which is required to install, but in my case I have already those libraries in install. Okay guys, so there are commands like you need to install TensorFlow REST serving API. Okay, and also you required same version of TensorFlow GPUs. Okay, and now I'm going to use noshup command. Noshup command is basically let the model to be run even when you moved out from the terminal. Okay, and my model name, I can put this model name anything, so let me name it anything. Okay, so model path, yeah, that's important. So my model path is here, so I'm going to copy this model path, absolute path, and I will paste that model path here. Okay, so inside this model, basically this is the V1 type of model. So what I need here to do, I need to copy those library and create a folder by V1. By default, TensorFlow try to locate the versions of the machine learning models available in the main directory. So this here I gave the directory path where my model is saved, and inside those model, okay, TensorFlow REST server trying to locate the version 1 model type, and my server log, this will show me entire information whatever the going on, if any error will be occur. So let me run this serve. My port number is 8080, so this is the REST port number, and let me open the folder again. Okay, and this is my serve log. You can see that model, so model is running now, entering the event loop. Let me show you guys in detail. Okay, this is the basically noshup output will be written. So no markup data file, basically as such my assert.extra folder is empty. So my model is now okay, up and running, and it is running on port number 8088. Okay, now this model need REST call where we can put the image and run it. So let's say I'm going to use that first let me make a REST call for this model. So as I run it for port number 8080, so, and my model name is anything, so let me write here anything. Okay, and it's running on local anything. Now I need to read some images, and let's see how much time it is taking for the prediction purpose. Okay, now my few images are already present in some folder. Let me take the same folder for now. Okay, I'm going to use this folder, copy reference path, okay, copy absolute path. So here few images are available. I'm again using globe. Okay, once my files is loaded, this sorry, this will make a REST call on my loaded model. And just a second guys, so anything, Okay, prediction data header. So whenever we require to call that model, basically the entire architecture will this model take input from by default serving default instance, and it takes as a image as an JSON input and produce an output which is used for the prediction purpose. Right now we have only the 3 classes, so we need some CSV file format which will be which contain the class names. So let me open a file. Okay, I'm going to delete entire files here, and labels should be read. Just a second. Cancer annulare kerato. Okay guys, so this CSV file used for labeling the outcome of the prediction. So I name this CSV file video D. Okay guys, so this is a basic Flask API I am using to call that TensorRest server port. Okay, and the model is deployed, model name is anything, deployed in port number 8088, and so it's running on localhost port number 8088. The version of model is v1, model name is anything, and data will be loaded from the folders and will be feed here, and this it will create a post request. This post request produce an JSON response. Okay, and that JSON response consists JSON response consists our predictions. That prediction will be we'll get here. The after getting the prediction type, we need to take np.argument max corresponding index value. This will produce the result, and that result will be feed in our main method where its class name is being produced. Okay, so let me run that REST server API. Okay, first, and let's see whether it is running fine or not. WC debug mode off. Just a second please. Okay, so port number 8000 I'm going to use here. 80 port is used for production purpose, so that's why. So my Flask application is up and running at port number 8000, while as you can see here at the terminal portion, the TensorRest server is already running. So let me make a call for the let me use image and see whether it will be able to produce the prediction or not. So I'm going to run this local running API and taking concerning for cancer, the images from the concerning from cancer, and each time these images being load, it create a post request, and the URL is here, and what is the URL name? Just a second. So URL name is im.site. Okay, it's running on port number 8000. Okay, this URL will be used will take a post request, takes the image and produce a JSON response as an output. So just a second, let me see what was the error. Oh, sorry, the error is this. So let me reach out to that file. Okay guys, now it's okay, fine. Let me rerun, terminate. Let me rerun the REST API first. Okay, now it's up and running. Let's see. And let's see what is error now. Okay, got it. REST API. So the basically right now I'm calling reading these images, image open file, when file got dot stream and try to reshape. Just a second. The way we create the input stream need to be ideally same. So if image is in some other type of format, it should convert into RGB format first. So okay, now again run REST and call postman. Okay guys, here you can see it start generating, producing the output, and let me see what those output are look like. Just a second. Reading the class name, list, prediction, json.dump, even anything. It's running port number 8088, JSON response 200, prediction results. Sorry. Okay guys, labels information. Let me see the pattern of labels also. This is important. So labels.shape convert. Wait. Okay, this is for printing the prediction. Okay, so that everything will be fine. Now everything is okay. So the REST API is already running and it's keep producing the output. I'm stopping, terminating it, and terminating it. Reach out to the terminal. It's running at port 088. Tensor REST server. Skin project v1. Okay, guys. Now let me run this Flask API first. It's up and running. This will take the port, image size, read. Okay, now it's good. So you can see here it taking the input images and producing the output, and we can also see the index value of the prediction. Okay, so every time so this index value is 1, so producing output will read the one label from the this label videos label.csv and keep producing the output. You can similarly deploy this on any type of cloud server and create a Docker image, correspondingly containerize the application and directly deploy onto it. So important part is if you can read about how this tensor REST serving is work and what are the important of it. And okay, so this is all about today. Thank you guys, thanks for watching the video.